I came up with a series of interfaces that encourages the use of bicycle helmets. Most of these were coded in processing and use webcams mounted to the bicycle to track the presence of people and objects. One webcam uses face detection to indicate whether a rider is present, and the other uses Reactivision's fiducial tracking to indicate whether or not the rider is wearing a helmet. There are other technologies that would enable this same sensory function, but for the purposes of iterative prototyping, webcam tracking is fairly quick and simple. A threat monitor gathers information from both the rider and the environment and delivers a visual feedback mechanism tracking the level of danger to the cyclist. This prototype just responds to whether the rider has a helmet on, but a more robust system could incorporate information like traffic density and weather. However, because a helmet is such a huge component of road safety, a rider without a helmet would always be reminded by a high threat indicator. Another interface checks whether the rider is wearing a helmet upon mounting the bicycle, and if no helmet is present, a text message is automatically sent to a family member, significant other, or close friend urging that contact to call the rider. This system leverages emotional guilt and personal responsibility, as the rider who fails to wear a helmet causes a loved one unnecessary anxiety. Using a simple frame capture system, an interface could gather photo data about a rider's helmet-wearing habits for easy sharing amongst a peer group. The picture could automatically be posted to the rider's Facebook wall, soliciting an immediate response from his or her peer group. Frequent postings without a helmet would likely result in scolding from friends, whereas postings with a helmet on would spark encouraging remarks. An LED interface provides simple, intuitive feedback to the rider and any surrounding people. When the cyclist mounts the bike, a red LED indicates no helmet has been detected. A green LED indicates that the rider is wearing a helmet and it's safe to proceed. As with many of the other interfaces, this system derives its power from social influences. The LEDs raise awareness of helmet-wearing habits from other cyclists, pedestrians, and motorists. Audio feedback could also be used to alert the rider and any passers-by in a more intrusive manner. When a rider mounts the bike without a helmet, an alarm sounds. The bike announces no helmet with a buzzer until a helmet is detected, at which point the bike welcomes the rider and starts up a cycling soundtrack. The annoying buzzer is a public nuisance, so social pressure is a contributing factor to the rider's decision to wear a helmet. This same system of monitoring could be turned around to face the community of cyclists around the rider. So an interface could compile statistics about the percentage of riders wearing helmets, which is the majority in San Francisco. A simple display would inform the rider of how many cyclists he or she has passed and how many of those were wearing helmets, encouraging the rider to follow the majority. Again, this interface invokes the idea of peer pressure in encouraging helmet use. A simple solution that doesn't rely on technology involves inscribing the bike's tires with messages that remind the rider to wear a helmet. Situating these messages on the tire make them hard to ignore as the rider stares down at them upon mounting the bike, and as they spin, they invite curiosity. Away from the bicycle, there are other ways of encouraging helmet use. One quick example would be a mobile cycling map plugin that ascertained whether the user was wearing a helmet. If no helmet was detected, the application would penalize the rider by delaying access to the maps. This type of reinforcement could persuade a user to wear a helmet just to avoid the frustration of waiting.